Okay, you see this question, and this is a very nice question in which there are three terminals x, y, and z, and at each of these 3 points x, y, and z, some or the other potential is defined. For example, potential of x point is v naught sin omega t. Similarly, there is a potential of y and potential of z also defined. Now x and y are connected uh, via a voltmeter, or voltmeter is connected between the points x and y. So this voltmeter V1 will measure the potential difference between x and y. So the measurement of V1 will be like voltage of y minus voltage of x, or voltage of x minus voltage of y. Anyway, we are concerned with the magnitude only. So let us take the measurement of V1 to be voltage of y minus voltage of x. Voltage of y is already given to be v naught sin omega t plus 2 pi by 3, and similarly voltage of x is also given to be v naught sin omega t. Subtract them. Now subtracting means like if there is a minus sign here, you can see this minus sign. So this minus sign can be absorbed by adding pi in the argument of the sine function, and so this v1, which is actually vy minus vx, this v1 can be written in this way. Now it's like addition of two sine function. One sine function having a phase of omega t plus 2 pi by 3, other sine function is like having a phase of omega t plus pi. Now adding the two sine functions is like adding the two vectors. Here the magnitude of the vector is the amplitude of the sine function. The first sine function has an amplitude of v naught. The second sine function also has an amplitude v naught. So the magnitude of the two vectors will be v naught and v naught. And the angle between the two vectors is the phase difference between the two SHMs. First SHM having a phase of omega t plus pi. Second SHM having a phase of omega t plus 2 pi by 3. If you subtract their phases, you will get pi by 3. So the angle between the vectors is pi by 3 or 60 degree. What is the v resultant? Here you can do vector addition and get the v resultant to be v naught root 3. Now here the resultant vector is representing the equivalent or the resultant sine function, and so the resultant will have a magnitude equal to the amplitude of the resultant sine function. And so the max value of the v resultant is equal to v naught root 3. But what the voltmeter measures is not the max value. Voltmeter will always measure RMS value. So the v1 reading will be v naught root 3 by root 2. Same way you can calculate v2 also. So what is v2? v2 is the potential difference between z and y, which is equal to voltage of z minus the voltage of y. Voltage of z is this, which is already given in the question. From here subtract the voltage of y. So that's what you will do. So this is voltage of z, and here we have the voltage of y. Again, to absorb the negative sign, what we can do is add pi into the argument of the sine function. So here we have added the pi, so it becomes like 5 pi by 3 kind of thing. Now again you will see that this is one sine function, this is another sine function, and like you are adding the two sine functions and adding the two sine functions like adding the two vectors. Now here the phase difference between the two vectors, sorry, the angle between the two vectors is equal to the phase difference between the sine function that they are representing. So when you do the phase difference, you will get omega t plus pi plus 2 pi by 3 minus omega t plus 4 pi by 3, which is again pi by 3. So the angle between the two vectors is again pi by 3 only. So because the angle is same, the amplitude is same, the magnitude is same, I mean, and so the resultant will be same thing like v naught root 3, and the RMS value will be v naught root 3 by root 2. And so in this case also vy minus vz also we are getting it to be same, so the ratio is going to be 1.